A very warm good morning to all. Welcome to ENVIRON 2020 National Online Lecture Series, Day 2, which is hosted by Department of Geology, Sahara College of Advanced Studies, in association with Center for Environment and Development, Trivandrum. Hope I am audible to everyone.
Yes. Yes.
Okay, thank you all for joining with us for the second section in this lecture series. It is my pleasure to invite Dr. Matthew Paul Oaken, Vice Principal, Sahara College, for the felicitation.
Good morning to all. Am I audible to you?
Yes, sir. We can hear you.
Distinguished Sri A C Dinesh, Director, GSI Mangalore, the Chief Guest and Resource Person of this National Lecture Series, Dr. P.O. Jensen, Principal, Sahradaya College of Advanced Studies, Kodagara, Thrissur, Professor K.J. Davis, Head of the Department of Geology, Sahradaya College, research scholars, invited guests, teachers and students from other institutions and from Sahradaya College. It is my pleasure and privilege to felicitate on the second day of this National Online Lecture Series and deliver a few words of blessings on this National Lecture Series organized by the Department of Geology, Sahradaya College of Advanced Studies, Kottagara, Thrissur, in association with Center for Environment and Development, Thiruvananthapuram. Sahradaya College of Advanced Studies, established in 2012, is founded and managed by Irinjalakuda Diocesan Educational Trust with its motto as Ever to Excel. Ever since 2016, when the Department of Geology was started, it has been faring well, and with 2 Calicut University ranks in this academic year, it has now earned a formidable reputation with excellent teachers and top-ranking students. I congratulate the head of the department, Professor K.J. Davis, and other faculty members for this marvelous achievement and for organizing this 4-day National Lecture Series. Let this 4-day lecture series, ENVIRON 2020, be a fruitful one to all the participants and to the society at large. Let this seminar create a platform to explore the recent trends in geology. On behalf of Sahradaya College of Advanced Studies, Kodagara, Thrissur, I thank Sri A C Dinesh, Director GSI, Mangalore, the resource person of the second day of the lecture series. I wish this 4-day lecture series all success and extend on behalf of the college warm greetings to all the resource persons, delegates, teachers and students from other institutions and from Sahradaya College. Thanking you. I conclude.
Thank you very much, sir. Now we will move on to our second lecture, Marine Sediment Distribution in World Oceans by Mr. A C Dinesh, Director, Marine and Coastal Survey Division, Geological Survey of India, Mangalore. A reminder to everyone, please turn off your cameras and microphones for the smooth conduct of the session. And if you have any doubts during the session, you can type it in the chat box. Also, attendance is mandatory for receiving the e-certificate. For that, feedback form will be shared through. Hello? Okay, feedback form will be shared during the end of the session. Now, I invite Dr. Colleen Elizabeth, Faculty, Department of Geology, to introduce our resource person.
Very good morning to one and all. Am I audible?
Yes, ma'am, you are audible.
Okay, thank you. Today, we are having Mr. A C Dinesh, Director, Marine and Coastal Survey Division, Geological Survey of India, Mangalore. He completed his post-graduation from Cochin University of Science and Technology and joined Geological Survey of India in 1988. Since 1995 onwards, He is in the Marine and Coastal Survey Division of Geological Survey of India and participated more than 40 cruise programs. And his major works include conceptualization of offshore mineral deposits within Indian Ocean, marine resource evaluation, development of softwares, preparation of databases and handbooks. He published 21 papers in national and 5 papers in international journals, and he developed 13 softwares. He also prepared 8 handbooks on different themes regarding his own works. With this, I invite Mr. A C Dinesh for his presentation. Welcome, sir.
Thank you very much, and a warm good morning to one and all. At the outset, I express my sincere thanks to Professor and Dr. Davis, who is my friend and college mate in Cochin University of Science and Technology. And I also express my sincere thanks to the authorities of this college, Truchur. Then, shall I start now, or somebody has to join? Some more has to join now?
No, sir, you can start. No, sir, you can start.
Okay. Now, yesterday I had a small talk with Dr. Davis, that I want to know whether any undergraduate and postgraduate, how many are there in attending the webinar. So then I was told that there are about half is from BSc course. Because my entire preparation, actually I am not interested in giving any lecture. Rather, I am interested in interactive classes, whether it is offline or online. So entire our presentations, preparations, all these documents, all based on postgraduate students and research scholars. So I was a bit confused because I talked around 9:30 yesterday night. So what to do? Because graduates, the BSc students, it may be bit difficult to follow certain things because they are not studied. That is not there in the curriculum. That is not their mistake. Many terminology they must have now come across. So, but then I decided I'll be giving a presentation and explain most of the terminology, and they can ask questions. And I will not stick to my entire presentation because that may not be possible to complete. Because the marine sediments in the world ocean, it takes 1 or 2 days, 2 days, because when we conduct the workshops, it takes a lot of time because a lot of questions and exercises. They have to do a lot of exercises and they have to ask so many questions. A lot of interaction is necessary for making a clear understanding of the marine sediment distribution. Because before that, they should know about the ocean floor, about the ocean. Then only they can learn about the marine sediments. So straight away, jumping into the marine sediment presentation, it may not be very much fruitful because since more than half of the participants are from BSc. So I will start my presentation. I will start with the basics of ocean floor. Is it okay? Is it okay?
Okay, sir.
No, I want to listen from the HOD. Is it okay? Not audible, not audible. Davis, you are not audible. Not audible, not audible, not audible. Davis.
Davis, sir. For me, it is audible.
No, I am not here listening from Dr. Davis. Any issue with me or can you repeat, Davis?
Sir, it's audible, sir.
For you, it is audible. Okay.
Yes,
okay.
sir.
What he told? What he told? What he told?
I think Davis, sir, mic is switch off. That was the problem. For all others, it is audible.
Oh, okay. What he told? What he told now?
We can't hear, sir. We can't hear his words.
Okay. So then I will start with the ocean floor, the basics of ocean floor. Then we will come to the marine sediments. Okay. Is it okay?
Okay, sir.
Are you able to see any window now?
Yes, sir. It's visible.
Visible, no? Okay.
Yes, sir.
Thank you. So now, chat box. I am not getting the chat box. 1 minute. You are getting the window, no?
No, sir. Some black shading only.
1 minute. Now?
Yes, sir.
Okay. Now, you see, the ocean floor, I need not elaborate on that one. It is uh, very large, very dynamic, and least understood on the earth. That is the least understood portion on the earth. That is ocean. Just like our space, which is the least understood. Ocean also least understood. We know about the ocean very little. And whatever we know, very little, that is also going on changing our understanding with the time and technology. So that's why, and on the land also same case, science is all about that. Science is ever changing with the time and technology, it changes. So there is no real truth in science because now most of the time it is apparent truth because every day, every time it may change. So now here coming to the ocean floor is mainly divided into three principal provinces, three principal areas, that is continental margins, mid-ocean ridges, and the deep ocean floors. So these are the important oceans on our Earth: Pacific Ocean, then Atlantic Ocean, Indian Ocean. Okay, these are the major ocean. Arctic Ocean is also there, not very large. So these three oceans, it controls the entire phenomenon on the earth. Because you see, though it is the least understood, we know that ocean has got the maximum influence on the land, on the climate, all type of movements. Everything is controlled by the ocean. The food security, the climate, everything is controlled by the ocean. So that much it is powerful. All the process going on in the ocean, on the surface, as well as in the deeper part, is have some influence on the entire earth. Now, these are the three major divisions on the ocean floor: continental margins and mid-ocean ridges and deep ocean floors. Whether you heard this one, I don't know. But now you please remember this. I will be sending the presentation to the organizers, so you can share it. So no need of writing anything, but you please remember this. I will ask.
Okay, sir.
So now you see there is a map and there is a cross section below that. So this is a simple cross section along an ocean. So most of the ocean you will get these features. One will be continental margin, then there will be a deep ocean floor, then there will be a mid-ocean ridge. Again, it will be repeating deep ocean floor, continental margin, and the land. So everywhere it is like that. What could be the reason for that? You see, it is symmetric most of. You see, it is symmetric. No, that mid-ocean floor is there at the center, and either side, you see, just the left-hand side and right-hand side, deep ocean floor that is known as abyssal plain. Then after that, continental margin. Then only the land comes. You see, North America and Africa, either side it is there. What could be the reason for why it is symmetric? This side and that side, it is same. Geomorphic units are same. What could be the reason? Anybody, please tell. Rohit. Well, Rohit is there, no? In the participant, among the participants. Rohit is there.
No,
No,
sir,
Rohit.
he is not here. No, not here.
No, I just told a name. That's all. So that means that Rohit is there. Okay. So anybody, I don't know any of your names, but Abhijit, anybody tell the answer. What could be the reason? Why it is having symmetric? The geomorphic units, the left-hand side of the mid-ocean ridge and right-hand side are same. Just tell a wrong answer, no problem. Just tell, I want to hear some sound. Be bold, nothing to lose. You tell some wrong answer. I'll be very happy. From the wrong, we will come to the right. Nobody said that means you are not relaxed. You are still in a rigid form. That's why you are not able to. You shout some answer. What could be the reason for this? Why it is symmetric left hand side and right hand side? Nobody has responded. Okay. This time I will tell the answer. So next time you shout some answer. I want wrong answers. Okay. Let us see. So the reason is that it has been split. This, you must have heard the seafloor spreading. Seafloor spreading. Anybody? How many have heard about seafloor spreading? Just switch on your mic and shout. No, please shout your answer.
Sir, it's from the divergent plate boundary, the magma from the ocean.
Very good. Good answer. Yes. Anybody else? Yeah, that means you have heard about seafloor spreading. You heard about seafloor spreading, isn't it?
Yes.
What about BSc? Anybody from BSc? I think you are from MSc. You are from MSc, postgraduates. Is it so?
No, sir, I am BSc third year. Fine.
Very good. What's your name?
Neha.
Okay, very good. Good answer. You are from which college?
From Sahardaya College of Advanced Studies.
Very good, Neha. You keep it up. That means you heard about seafloor spreading. So earlier, the Africa, South America, they were together, and there was a split along some cracks developed, and that's a long process to talk about. Then that will be the continents will be split. Then seafloor spreading, that is new ocean floor will be forming. Still it is forming all along the mid-ocean ridges, around 80,000 kilometer long ocean ridges along the seafloor. It is there. That is a huge, this is a real, a real surprise to everybody. Because 80,000 kilometer long mid-ocean ridges, mountain chains are there in the ocean bottom. Okay, so that means this has been split. One single land has been split into two pieces. Then in between, what is happening? A mid-ocean ridge is forming. Then either side, you are getting slowly the newly formed ocean floor will be moving away from the ocean ridge, mid-ocean ridge, then forming what is that abyssal plain and other things. So the continental portion, the land portion, you will get a continental margin, and in between the mid-ocean ridge and the continental margin, you will get a plain, abyssal plain, deep ocean floor. So that means the symmetry is because either side you are getting, because these have been formed from a splitting of a single land. That's why if you cut a piece of paper, into two halves, you will get just like a jigsaw puzzle. You can match it together. So in between, something has happened. That means a new ocean floor is being created. So the two land pieces are moving away from the mid-ocean bridge because it is moving. It is a new ocean floor is just coming up and occupying the space. So land cannot be together. It has to move away. Is it okay now? You understood that? Shout. Shout your answer. I want a very active, interactive session. Not I am lecturing something and you are listening or not listening. No. Please. You shout your answer. Is it okay? You understood this?
Yes, sir.
Same. Anybody else? That Neha has told us, no? Who has told yes? Please tell your name. Am I audible? Please tell your name. Who has told yes? Is it now whether you understood this? Now am I audible?
You are audible, sir. You are audible.
But there is no response. No response. Whether audible to all. No response. Neha, whether now it is understood to you. What about others? I want to hear from the BSc students, not from the MSc. Anybody else? Is it understood to you? You switch on your mic, please, and tell whether understood or not. You can tell a no, then you can tell a yes. There is no issue. Is it okay? Whether I should repeat again? I should repeat it.
No, sir.
Okay. Okay. Now you see, this is a simple cross section and of an ocean floor. A simple one. It may not be the case with everywhere because there will be changes. There will be a lot of other geomorphic units also will be there. But this is a generalized picture. Now you may be you have heard this word continental margin. The main three provinces are continental margins, then deep ocean floor and mid-ocean ridges. So one is continental margin. Continental margin, the moment you hear, you may think that where the land ends, that is a continental margin, where the continent ends. But that is not the case. Actually, for our understanding, our continent ends where the ocean starts. Isn't it? Is it not? Our understanding, normal, a general perception will be where the continent ends, and that will be the continental margin, and from where the ocean starts. But actually, it is not the case. A continental margin is not even a submerged portion. Submerged under ocean is also a part of continent, because while splitting a single piece of land into two pieces, a lot of area of the continent has been submerged under the ocean. A lot of area has been submerged under the ocean because the water has been incurred, that means water has entered into the land portion. That portion, the submerged portion, also part of the continent, though it is underwater. Is it understood? You understood that one? So the continental margin is not the edge of the continent where from the ocean starts. The continental margin is somewhere lying in the ocean. That means it includes not only the land portion, the continental shelf, then slope and the rise, some portion of the rise. These are three main things also part of any continent. So these three also together with the continent, so that means the continental margin somewhere in the ocean. After the continental shelf, there will be a slope. Along the slope, that actual cut has been taken place, the splitting. Continental slope is there, then will be a rise. Rise means the slumped sediments from the continental slope and the shelf will be piling up. That is a continental rise. Then these three together coming as a part of the continental margin. Also, so many island arcs, backarc basins, marine canyons, and some part of fans. That I will not elaborate on those things because I don't want to complicate the things. So at least you remember a continental margin includes the continental shelf, slope, rise, and because the actual continental margin to identify, you have to do some magnetic gravity and seismic survey. Then only you can determine the actual where the actual continental margin lies, and from where the ocean flow, that means mainly the basaltic flow starts. Okay, the continental pieces, continental area will be mainly, it will not be basaltic, it will be more silicic, lighter material, granitic, and the ocean floor will be mainly basaltic. So that also you must have studied in the third year BSc. So these are part of continental margin. That means it includes continental shelf, slopes, and rise, and also so many other features: island arcs, backarc basin. These are all connected to plate tectonics, seafloor spreading, plate tectonics. That means subduction, abduction. So many dynamic processes are happening on the earth. That means it's a continuous process. Okay, so all lot of dynamic processes are happening. So it is a very interesting subject. If you want to know about the seafloor spreading, then plate tectonics and the dynamic process all over the world, it is happening because of the seafloor spreading and subduction. Okay, so I am moving to the next one. This is a schematic diagram on the ocean floor. Now you see continental shelf. It is slightly up because it is a part of the continent. It is a part of the continental shelf is a part of the continent. That material is granitic mainly. That means lighter material. Granite doesn't mean that pure granite. It will be a combination. Granite will be there, granite will be there. So many things. Okay, I mean to say it's a lighter rocks compared to the ocean floor. That's mostly basaltic. That doesn't mean that the entire ocean floor is basaltic. It is will be gabbro will be there certain places. That is especially in the ocean places. Then some ultramorphics will be there. Ultramorphic rocks will be there. Okay, some dikes will be there. So that is okay. Now you see continental shelf is there. That is part of the continental crust. So continental shelf and the continental slope. That means just after the splitting, there will be the continental shelf and a slope. Along the slope, a lot of sediments will be dumping or sliding along the slope. How the sediments will be reaching there? How the sediments will be reaching at the end of the continental shelf? How the sediments will be reaching? Anybody, please. How the sediments will be reaching at the edge of the continental shelf? Then only it will be slumping. No. How the sediments will be reaching there? Continental shelf is how it will be far away. Some continents, the shelf edge will be far away. That means some will be very near. That depends where it was split. Okay, in India, some places we are getting the continental shelf edge 100 kilometer away, 80 kilometer away. Some places is 150 kilometer. It varies. And the east coast it is very near, and west coast it is slightly not every place. East coast certain places is very near the shelf edge. So we are getting the shelf edge at 90 meter water depth or 100 meter, 110, 200 meter, like that. It varies. Okay. So where from the sediments reach on the shelf edge for slumping? Anybody, please tell. How the sediments are reaching on the shelf edge? Where from it is coming?
Sediments from the land part due to the erosion and transportation and deposition, it's reaching the continental shelf part.
How? What is a transporting media? Yes, good answer. Very good answer.
Transporting media, streams mainly.
Streams, whether streams will flow underwater Here the corner shelf heads, what is happening? I will explain that. Yes, good, very good. On the shelf edge, you see the transportation by rivers that mainly that they dump the material on the near to the shore. Into their river mouth, they will be dumping the material. After that, river is not flowing. Okay, in the under the on the ocean floor, river is not flowing, but these sediments, the major rivers, for example, Indus River, then Ganges and Brahmaputra, Amazon, then these type of major rivers, after dumping huge amount of material in the mouth, river mouth, near to the river mouth, what is happening? That will be piling up slowly due to the gradual slope. On the continental shelf slope will be around 0.1 degree, very less, 0.1 degree. Even on the continental slope, it will average will be around 0.4, 0.3, 0.4, like that. Okay, some places it will be vary. That depends upon the geomorphology. So slowly it will be sliding. Then wave also will be taking some finer material into the offshore. Suspended material will be there. That will be getting settling. And a lot of biological activities also will be happening throughout the ocean floor, entire ocean floor. Wherever light is there, wherever oxygen is there in the water, wherever carbon dioxide is there, a lot of activities are happening. A lot of biological production, the phytoplankton, zooplankton, all these production will be happening on the ocean floor up to about 100-meter water depth. On the ocean floor, about 100-meter terrific activities will be there. Top 30 or 50 meters, very, very large activities depending upon the sunlight, depending upon the oxygen, depending upon the carbon dioxide, and depending upon acidification. There will be less acidification, you will get more production because that will be slowly getting dissolved, the shells and dust. That is a major problem now we are facing because of the increased carbon dioxide content in the atmosphere. Okay, the acidification already started because the increased carbon dioxide content we are experiencing after the industrial revolution. That means after 1950s, the tremendous increase in the atmospheric carbon dioxide has happened. That's why this climate changes and all. Okay, all depends upon the greenhouse gases effect in the atmosphere and so many other factors too. So these material, biologic material, lot of dust and shell, the hard portion. That means mainly it is calcium carbonate, very less production of SiO2, silica, that is diatoms and radiolarians, that is mainly siliceous material organisms. Their hard part will be made of silica, whereas most of the other species, they make calcium carbonate as their dust and shell. Okay, so this will be falling from the surface after their death. This will be falling slowly. Their dust and shells will be test means TESTS. Test means small shell. That is known as test. Okay, don't get confused. So tests and shells will be slowly falling from the ocean floor. That also contribute immensely on the shelf edge. It will be there. Everywhere it is falling. So it will be getting accumulated. And the material coming from the land, lot of material, that depends. In the tropical areas like between 22 degrees, that is between around 30 degree north and 30 degree south, in between, lot of activities, physical and chemical weathering. So that lot of production of material is there. Maximum production of transporting material, that means sand, silt, clay happening where? Due to chemical weathering or physical weathering? That's a question I'm asking. The weathering product will be maximum due to chemical weathering or physical weathering. Chemical weathering you must have heard in BSc. Physical weathering also you must have heard. Where the maximum production of material. That means the weathered product, where you can expect. Where you can expect. No answer. Okay. So, you see, chemical weathering will contribute. We think that physical weathering will break down the rock into pieces. No, that is breaking down. There is no issue. But the amount of material that is being produced will be maximum by chemical weathering. Then, of course, there will be physical agency should be there, because wind, then water, through this one, waves and all, that will be getting transported into the ocean. So chemical weathering will facilitate maximum breaking down of the rocks and minerals. So that will break down, then it will be taken away by the wind, taken away by rivers, streams, and waves and currents. And at last, where is the sinking place? Where is the destination of this material from the land? At last, it will reach in the ocean. Okay, and from the ocean, the coarser material, that is very coarse material, bigger material, that will be lying deposited very near to the shoreline, and the finer material will be moving away from the shoreline. Because why? What is the reason? Why the coarser material will be remaining on the shore, and the finer material is moving away? What is the reason? No, you see, if you being a geologist, after joining the geology course, a geology is nothing but mainly it is a science of common sense and observation. You observe, apply your common sense. That is the main part of geology. To become a good geologist, you should be a good observer, and you should be a good thinker, and you should with a good common sense. So everything, every process around you, you should start observing. So now you see, I am throwing a question. Why we are getting the coarser material, comparatively coarser material on the shore? The finer material we are not getting, except some areas. I will tell the answer for that. What is the reason? Yes, anybody?
Because of the weight of the material.
Only then for finer material also there is a weight. Why it is not reserving on the shore, near to the shoreline or beach? Why only coarser material we are getting on the beach? If you move away,
finer material is easy to travel, and coarser material is not so easily transported. That's why it is supposed to be the shoreline.
Transported by what medium, what agency?
Transported by the.
Tell me. Tell. Please tell. You are right. You are right.
Transported by the ocean water.
Ocean water, there is a name, no. That agency has got a name, whether bus or auto rickshaw or train. That name will be there, no.
Waves.
Very good. Waves and waves and waves and
waves and currents.
Very good. Waves and currents. You see, on the shore, near on the beach, what is it? That is the most dynamic portion on the earth. Is the beaches. Every 24/7 dynamic. Anytime you go, no rush for that. Anytime you are getting waves that may be bigger in some places, moderate in some places, very small waves in some places. That all depends upon the wind energy. Wind also depending upon the geomorphology of the area, then humidity, temperature, so many things. Okay, but anyway, we are getting all the time. Most of the beaches will be under waves. So the waves and then currents will be there. Longshore currents will be there. So these agencies and tide also there. Tide also coming as currents and waves. So these waves and currents we can generalize two things. Waves and currents in the near to the shore that will carry the finer material away. And where it cannot carry, it will be dumping there. It cannot carry, then it will be putting. That means always you will get the coarser, comparatively coarser material. That means gravel, sand, very coarse sand, these type of material on the beach. And the silt and clay, the finer material that will be taken away from the shore into the deep ocean. It will be taken away. Got it? Understood? Understood? Is it clear? Is it clear?
Yes, sir. It is clear.
Yes, sir.
Only two sounds, and there is no. I am not hearing any large so many sound I am not hearing. You see, I am teaching now just like that, without seeing anybody. I am seeing only my screen. Only my screen, because I don't know, some setup problem is there. I am not seeing anybody. I am not able to keep this window on a side also. Okay, but you just shout whether it is understood or not. Shout.
Yes, sir.
Yes,
Yes,
sir.
sir.
It's clear.
Clear? Is it clear? I am not hearing any voice sound also. Always girls are very active and dynamic, just like a sea floor. Sorry, the beaches. They are very dynamic. Where there is no boy participant here. Nobody is there. Davis. No boy participant in this program. All are girls. No, I just tell answer. Nobody is there. No, out of curiosity, I am asking. Yes or no?
Yes, sir. It's clear.
Good. You relax first. Yeah, I am seeing somebody is very rigid and they are very fearful or skeptic. They are not coming. You see, this is a interactive lecture class. Not I told you, just I want to give some talk and go. Whatever I thought, I want that there should be some imprint in your memory. You should understand that. A little only. A little I want to convey. That's all. I don't want to take the entire marine sediments. Okay. Now you see, you shout your answer, wrong answer you shout, then you will be part of this interactive session. Okay. There is no harm. So you think whatever you think, you give the answer. Now you see, I told you in the continental shelf how the sediments are reaching. The sediments are being contributed from the land area. From the land, it is coming into the shore by the rivers, then wind, then any other glaciers in the temperate climate region, it will be by glaciers. Normally in the tropical areas, there is no glaciers. That is, they will be brought by mainly the rivers and streams and wind. Then there will be production of sediments by the coastal erosion, that means waves and currents in the ocean, in the near shore areas. So these are also contributing. And these sediments, the finer material will be moving away. The coarser material will be remaining on the beaches and near to the beach. So the finer material will come down because there is a slope about 0.1 or 0.15, 0.2 degree slope is there from the beach to the continental shelf edge. So certainly with the gravity also, it will be sliding slowly. There will be a tendency to going down into the shelf edge. Understood? So the shelf edge will get much material. And moreover, I told the material falling, the biological material, crust and shells falling from the ocean surface, that also contributing. So all these sediments with the biological components and the heterogeneous components. Heterogeneous sediment means which are originated from the land, from the rock. Okay, so these sediments are ready for getting slumped into the ocean floor, deep ocean floor. Because whenever it is getting filled because of gravity, and it will slump along the continental slope, and that's why the continental rise is being formed by depositing the sediments. Is it clear? Is it clear or not? Then we will go to the marine sediments.
Yes,
So many. Yes, very good, very good. I am listening to yes. Who is that? Name, please tell your name. Please tell your tell. Abhinav.
Yes, sir.
Abhinav from which college?
AWH Special College, Kallai.
Very good. That is Prabhakaran sir is there. Prabhakaran sir?
Yes, sir.
Yes.
Yeah, very good, very good. Okay. So Abhinav, is it clear to you now?
Yes, sir.
Is it clear? Very good,
Yes, sir.
very good. Good. Now you see any question you ask. Okay. Any question in between you can ask. Don't type in
Okay,
this
sir.
chat box. I am not seeing the chat box. That's why I cannot respond to that. Okay. Now,
Okay, sir.
shall I move to the next slide, Abhinav? Abhinav, shall I move to the next slide? You tell yes, very strong yes, you tell.
Yes, sir.
Very good. Okay. So anytime you can ask, you can expect questions. Be ready for that. And tell your answer, wrong answer. Okay, then we will again discuss on that. I don't want any right answer. Wrong answers you tell. Now you see this is the next one. Now coming to the, I told about the continental margin. What are the three types, three major provinces of the ocean floor? What are the three major provinces? Abhinav, you please tell. What are the three major provinces of the ocean floor? Abhinav, from Kalai, please tell. What are the three provinces, major provinces of the ocean floor? One is continental margin. Continental margin. Other one is, second one is Abhinav. Abhinav has gone. Abhinav.
Continental shelf.
No, not continental. I told you, continental shelf is a part of continental margin. So you can tell continental margin if you tell that includes continental shelf, continental slope, and continental rise, and so many other things that we are not discussing. So please tell continental margin. That includes the three: shelf, continental slope, and continental rise. Okay. So the major three provinces you tell me. Major three provinces.
Continental margin.
Very good. Either continental margin, then
Continental ridge.
not continental, mid-ocean ridges. Mid-ocean ridges. Okay, no problem. Mid-ocean ridges.
Deep ocean.
Very good, very good, very good. You remember that one? You understood. I hope others also understood this. Is it okay? So now we will come to the mid-ocean ridge. These are the three provinces. Continental margin. That includes mainly three: continental shelf, continental slope, and continental rise. Then comes after the continental rise, you are getting the deep ocean floor. Then comes a mid-ocean ridge standing in front of you, about 1,000 or 2,000 meter height. Height will be there. Sometimes just more than that. That will be very long, very tall one with a rugged nature. So much ruggedness will be there. Very sharp, hard. You cannot walk over that one. And that will be very rugged one. And that is that is long chain of mountain. That is occurring all along the ocean floor. That map I will show you. So that is really a mystery on the earth. Now we understood how it is forming. So it is no longer a mystery, but it is a real surprise to everybody. How this you see, the entire earth is full of mysteries and surprises. And many things you cannot explain. And many understanding of our understanding are wrong, absolutely wrong. Because with our present knowledge, we are telling that this is right. But after tomorrow, after 2 years, that will be a wrong perception. Okay, that's about science I already told. Now, mid-ocean ridges, MOR, the short form is MOR, mid-ocean ridges. These are mountain chains that occupy mostly middle part of the ocean floor of all oceans, that is running about 80,000 kilometers. Is it okay? I move to the next one. These are the schematic diagram, a map, not a diagram, a map on the mid-ocean ridges. You see that red one. The red ones are the pink one, not red. That pink are the mid-ocean ridges chain. That's the mid-oceanic ridges. That is a chain. It is all continuous. See, all connected. Most of the places it is connected. So these are having different names in different places, in different ocean. There are a few names I will tell you. One is mid-ocean, we have got Carlsberg Ridge is there, Carlsberg Ridge. Then East Pacific Rise is there. Then Central Indian Ridge is there. Southeast Indian Ridge is there. Southwest Indian Ridge is there. Mid-Atlantic Ridge is there. So like that, so many ridges are there. Okay, these are all part of the long mid-oceanic ridge chain system. Is it clear? Is it clear? And this has been formed by splitting of the land of the continent into two portions, and because slowly the basaltic magma from the upper mantle is slowly coming through this split, through this what is that gap or crack, and occupying the space. That's why the split portion of the continents are moving away from the ocean ridge. So it is occupying slowly, and becoming a tall mountain. Okay, mountain chain. Is it okay? Is it okay? Is it very interesting to study about ocean ridges in different oceans? Okay, that is coming under a different topic. So now deep ocean floors. The text is more here. I don't want to keep this much text on a slide, but because this is actually for your understanding, I kept this. Deep ocean floors are broad, relatively smooth surfaces and consist of two sections. One is, you don't bother about this. Okay, if you don't bother also, no problem. Now you understood this is a third province. First province is Continental Margin. Then comes in the order, it comes the deep ocean floor that we are talking about. Then comes your mid-ocean ridge. We learned about Continental Margin and mid-ocean ridge. The another one is the deep ocean floor that is occurring in between mid-ocean ridge and the continental margin. So the deep ocean floors are broad and smooth surfaces, consist of two sections. One is abyssal plains and abyssal hills. A long plain will be there. More than that means more than around 2,500. Then some place. It's very interesting subject. When we learn about marine sediments, you will know how the sediments are occurring in different places of the ocean floor, different types of sediments, how they are coming, what is the reason for that. You will have that curiosity, and a major role is there on the climate of that area. A major role is the wind pattern. Major role is there for the ocean currents. These are all clubbed together. All are connected together, and these are all connected to our climate and our food security, everything. Without the ocean, there is no survival. Okay, so these, even for the tiny phytoplanktons, are the main reason for our food security. Without that, there is no zooplankton. Without that, there is no fish or any other higher order species cannot survive without the tiny material, tiny species. So everything is connected in the food cycle. If you cut one, it will then a huge impact will be there on the other species. So now the deep ocean floor is a broad, relatively smooth surfaces, and it has got two sections. One is abyssal plains, that is a major portion, and the other one is some places you will get some hills. Some hills, broad hills will be there. That's all. Okay. So then we'll go to the marine sediment. Now you see up to what time I can take this? Up to what time? Up to what time I can continue this lecture? No answer.
Hello, sir. Hello, Mr. Dinesh.
Hello.
Yes, Davis, please tell me.
Yeah, you can continue half an hour more, okay?
Okay. Okay, now this is about the ocean floor. Now, then I will move to the marine sediments. Okay. Any doubt is there? Please ask. Yeah, that 50 minutes break is over now. Not over.
That is not necessary. You can continue.
Okay. I can continue. Okay. So any doubt is there? Please ask. Please ask one doubt at least. I am taking the other presentation by that time.
Sir, the mid-ocean ridges, you talked about the mid-ocean ridges, right? Can they spread to the continents as well? In that map which you show.
What is the question? Please ask. No problem. Don't be nervous. Please ask.
In that map which you showed, the ridges were also on the continents.
No. Yes, that is in the map. You are seeing like that. It is not on the continent. It's not on the continent. There will be an ocean there. There will be part because in the entire Earth in a small map it is shown. So you are feeling. For example, Red Sea. Red Sea you take. If you take Red Sea, if you take Red Sea, where is Red Sea? Where is the Red Sea? It is between the Arabian Peninsula and Africa. There is a Red Sea. It's an African continent. Okay. Red Sea, you must have heard about Red Sea. Red Sea, there is a mid-ocean ridge on the in between the Red Sea. Seafloor spreading is there. But in a map, Red Sea will be a small sea. It is not a big ocean. So in the map, if you see it, you will feel that it is on the land. Okay. It is on the land. Even the ridges are being formed. Now see, there is an afar triangle. A triple junction is there. That is, there is the northeastern part of northeastern part of Africa. There, the spreading you can see with your eyes on the land because that is coming. The basaltic magma is just spewing out from the cracks, through the cracks. You can see all that is there. That is happening in the that area is not Somalia. That is I'm not getting the name of that place. That area you can see on the desert. It is happening. The seafloor spreading is happening. That is coming because there we are getting a new plate boundary. That is the East African Rift Valley. That is being formed. It is being cracked now. Already cracked. Valley has been formed. Now the Africa will be splitting into two half. One will be western side will be a major portion. Eastern side will be including the Kenya or Somalia, all these places, eastern side. Okay, Mozambique, all these places will be in the eastern side, and western side will be all other major portion of Africa. So that is going to be split. Already it is in the beginning. Just like you can see with your naked eyes, how the seafloor spreading is about to start. So it's a long process. It takes millions of years to reach that stage. Now it is a very embryonic, not embryonic, it is a very preliminary stage. Okay, so Red Sea is just an embryonic stage. But the Mediterranean Sea, it is in the almost terminal stage, it's already over. It is done. There is no more subduction happening there. Africa is already halted there. So Africa, because why Africa has been split along the eastern Rift Valley, East African Rift Valley, because Africa is the only country which is having under total compression. So you see, any part you take, if you think about Africa, any part you take, Africa has been compressed from all sides. The western side, Mid-Atlantic ridge, eastern side, Indian Ocean, so many ridges are there. Southern side also, the southeast, Indian ridge, southwest Indian ridge is there. Everywhere, Mid-Ocean ridge, everywhere there it is getting pushed. And the northern side, no more subduction happening. So it is not able to relax anywhere. So there is no relaxation. There is no divergence happening through which it can relax. Everywhere compression. So it is getting arched up. It is bent. African continent is bent. Then it is cracked now along the East African Rift Valley. So now it is forming, slowly forming into two plates. Then slowly, after millions of years, there will be a ocean, narrow, shallow ocean will be formed. Sea will be formed, just like Red Sea. So Red Sea, you are seeing, there's a small one. That's why you are seeing that it is on the land. Okay, is it clear now? Is it clear?
Yes, sir. Yes, sir.
Okay, I am not bothered about how much I can complete. Okay, that's why the marine sediments I cannot complete, I am sure. Flow for our sediment classification and biota classification, we are making two broad classification. One is pelagic, other one is benthic. Pelagic means that means whatever in the ocean water, that is known as pelagic, and benthic is related to the ocean floor. Benthic, entire ocean floor is known as benthic. Is it clear? Then you can argue that then the benthic is that with the ocean floor, we are dividing continental margin, that's a part of ocean floor, deep ocean floor, that's a part of ocean floor, and mid-ocean bridges, that's also part of ocean floor. So these three are coming under benthic. Okay, But normally we use benthic for sediments and organisms. Okay, not for any dynamic processes, our tectonic processes. Okay. So now is it clear now? Pelagic and benthic. Pelagic means connected to the water column. Anything in the water column, that is a pelagic. That means pelagic species. That means any organism, any animal or plant living in the water, ocean water. A benthic species, benthic organism, benthic animal means an animal living, dwelling on the ocean floor. Whether it's a sediment or rock on the ocean floor, it is dwelling, it is living, it is surviving. Is it clear? Pelagic and benthic. Two words you remember. Is it clear?
Yes, sir.
Yes. Oh,
Yes, sir.
Abhinav sound. And first sound who?
Yes, sir. It's clear.
What is your name? What's your name? Name. Your name.
Aisha.
Ah, very good. Aisha, is it clear to you?
Yes, sir.
Which college? You are from which college?
Sahrdaya.
Very good. Okay. So pelagic means related to the ocean water column and benthic means related to the ocean floor. So now, don't get confused. Pelagic is horizontally classified based on the distance from the shore. That means, I will show the map, that schematic diagram, then it will be clear. The pelagic I told you, it's the entire ocean water column is known as pelagic. Then, near to the land, near to the continent, up to certain distance, depending upon the distance from the continent, there is a division, that is neritic and oceanic. Neritic means found in waters above the continental margin, or especially continental shelf. You know what is shelf now, continental shelf. Above that water column, above the shelf, the water column. Those species or those sediments or anything, that water column is known as neritic. That column is known as, water column is known as neritic. That means the water column above the continental shelf or continental, you can call continental shelf mainly. The ocean water column above the continental shelf is known as neritic, and beyond that one, that is oceanic. Very deep ocean water is known as oceanic. That means neritic is the very near to the continent, that is very shallow, that is above the ocean continental shelf, maximum 200-meter water depth. That means 200-meter, maximum 200-meter water column is known as neritic, and above 200-meter water, that means away from the continental shelf, this entire water column is known as oceanic. Is it clear? This is a two classification of pelagic. The water column is divided on the basis of the distance from the continent, and it's neritic and oceanic. Now you see this, it will be clear. Okay? Now you see. This is, so many terminologies are there. Don't get perplexed or confused. Once you understand, it will be very easy. First, you will be feeling that it is very, very tough. Now you see. Pelagic province and benthic province. Pelagic, I told, you see, this is the pelagic, that is neritic and oceanic. The entire water column is known as pelagic. Here, the pelagic is shown, the entire water column, how it is divided, depending upon different water depth. That is, the pelagic is divided into epipelagic, that means up to 200-meter water column, top 200, 0 to 200 is epipelagic. Then mesopelagic is 200 to 1000 meter. Then bathypelagic is 1000 to 2000. Abyssal pelagic is 2000 to 6000 meter water column. And hadal pelagic is more than 6000, very deep ocean. That is more than 6000. That is occurring in only certain, mainly occurring in Pacific Ocean. Okay. Otherwise, at Atlantic Ocean, you cannot see about 6000 meter water depth. Mainly the deep ocean is Pacific. So, this is a water column definition. That is, pelagic province is divided into 5 divisions, subdivisions. That is epipelagic, mesopelagic, bathypelagic, abyssal pelagic, and hadal pelagic, depending upon the water depth. 0 to 200, 200 to 1000, 1000 to 2000, 2000 to 6000, and more than 6000. Whereas the benthic, that is ocean floor, that is benthic, the ocean floor also divided. Certain ocean floor will be between 0 to 200 meter water depth. Ocean floor will be there, and certain ocean floor will be 200 to 2000 meter water depth. ocean floor will be there. So these ocean floor will be different in the formation of species and the formation of sediments and so many things. All depends upon how much water column is the ocean floor is not uniform everywhere. Ocean floor, the characteristics of ocean floor is decided by how much water column is there above that. That is a determination. Okay, if it is only 10-meter water column, you can that ocean floor will be having lot of biodiversity, lot of biomass, lot of activities, currents, waves, so many things will be there. Just 10-meter below, 10-meter, the ocean floor is just 10-meter below. There, the species, the sediments, everything is different.
Hello, sir.
Hello, sir. Sorry for the inconvenience. The session will resume shortly. There is a slight network issue problem. In the meantime, if you have any doubts, you can ask now. The lecture will continue shortly. Meanwhile, day 3 lecture will be on 13th October, day after tomorrow at 9:30 a.m. on environmental degradation leading to landslides in Western Ghats by Dr. K. Ramachandran, scientist retired from NSS Trivandrum. Note that it will be on day after tomorrow, not tomorrow, on 13th of October at 9:30 a.m.
Hello. Hello.
പറഞ്ഞോളൂ.
We can hear you, sir.
Some technical problem. Sorry. Due to some technical problem, today program is going to wind up now. So I'm not getting the connection to A C Dinesh. It may be a technical problem. So we are going to wind up. Okay. Next we can go for a vote of thanks.
Now I invite Nandapriya, second year BSc Geology student, for delivering vote of thanks.
Am I audible?
Yes, you are audible.
Yes.
Good morning, everyone. Respected Principal Dr. P.U. Jensen, Vice Principal Dr. Matthews Polukan, our beloved HRD Professor Davis KJ, our honored guest Mr. A C Dinesh, faculty members, and dear participants. On behalf of Sahridaya College of Advanced Studies, I would like to express my gratitude to our chief guest, Mr. A C Dinesh, who spared his time for the webinar to help us explore more about ocean features and marine sediment distribution in world ocean. Thank you, sir, for the interesting and enlightening class. I would like to express a profound gratitude to our principal, Dr. P.O. Jensen, and vice principal, Dr. Matthews Paul Oken, for the presence and support. I would like to express my hearty thanks to our HOD, Professor Davis KJ, for the guidance, and I'm happy to express my gratitude to the teachers who have also made this webinar a great success. Last but not the least, a great appreciation and thanks to all participants who choose to be live with us and attend the webinar with an inquiring mind and made it a successful event. Once again, I thank you all for your presence and participation. Thank you.
Thank you all for attending day 2 lecture. Hope it will help